on cyclic quadrilateral and some more two things, right? So before I proceed to the present lesson, I want to remind you some of the things that we have seen in our previous lesson, and I will give you some more examples regarding central angle and inscribed angle, which was part of the discussion, right? So if you remember, a central angle is an angle whose vertex is on the circle and the sides are the radii of the circle, okay? So we defined as a central angle is an angle whose vertex is on the circle, on the center, and the sides are the radii, okay? So this can be a good example of a central angle. And in the discussion of the central angle, we have seen the relationship between the central angle and the arc subtending it. For example, if you consider this point A, the center is O, and the other point B on the circle, the measure of angle AOB is equal to the measure of the arc subtending the central angle, okay? This arc and the degree measure of this arc AB and the central angle AOB are the same, okay? So based on this definition, we have seen certain examples regarding central angle. The other thing is we have also seen inscribed angle, okay? An inscribed angle is an angle whose vertex is on the center and the sides are the chord, okay? Geometrically, if you have this circle, an inscribed angle is an angle whose vertex is on the circle, okay? Say this point is A, say this is B, and this is C. Okay, so this angle B or angle ABC is an angle formed by two intersecting chords. Okay, AB is a chord, BC is a chord, and they intersect at some point B on the circle. So this angle is called inscribed angle. And we have seen the relationship between the inscribed angle and the arc subtending it, okay? The degree measure of the inscribed angle ABC, and the arc subtending it is related by the degree measure of angle ABC is half of the degree measure of the arc AC. Okay, we have seen the proof of this thing. Okay, we derived this thing using a certain relationship. Okay, we were able to construct a diameter. Okay, just to remind you how we proved it, one of the chord can be a diameter. That was the case that we have taken, and the other thing is a chord. Okay, if you consider this AB as a diameter and BC as any chord, we can prove this angle is half of the arc BC by constructing a radii. Okay, since AB is a diameter, say this point is O. Okay, you can create different situation, but the situation that we have already taken is one of the chord is a diameter, the other is any ordinary chord. So by constructing a line segment from center to any point on the circle, this is R, right? So as you can see here, by definition, the distance from the center to any point on the circle is radius, and the radius is constant, right? You can construct in any direction. So you will have the radius. Now, if you see this picture and consider triangle BOC is an isosceles triangle. By definition, a triangle is said to be isosceles if two of its sides are the same. So in this case, these two are the same, and they are radius. So BOC is an isosceles triangle. And the other thing, if you consider this as X and this becomes X, Because in an isosceles triangle, two of its sides are congruent. Therefore, their corresponding angles are also congruent. So if this is x, assume that this part, okay, this central angle is theta. Okay, now you can create relationship between these angles and theta. Okay, if you remember in Unit 5, we have seen the relationship between two remote interior angles and the exterior angles, right? So x and x, these two x are remote interior angles and theta is exterior angles, so that you can create relationship between this thing. X plus x becomes theta, right? So this gives us 2x becomes theta. So whenever you solve for x, dividing both sides by 2, this x becomes half of theta. Okay, now this tells us something between the inscribed angle and the arc subtending it. Okay, this is x, and this is theta. By definition, the central angle and the arc subtending it are the same. So theta and measure of arc AC are the same. So in place of this theta, you can substitute arc AC, and this x is ABC. Okay, measure of angle ABC. Therefore, you can conclude that the measure of angle ABC is half of the arc subtending it. That means arc AC. This was the technique that we used to drive the relationship between the inscribed angle and the arc subtending it. Okay, so if I say shortly this much, let me give you some more examples regarding central angle and the arc subtending it. Okay, so look at this one. Probably this is the third example because we already we have seen two examples regarding inscribed angle. So let me give you one more interesting examples on this topic. Consider this diagram. Consider the diagram shown below. Okay, here we do have a certain circle. Say AB is a diameter. Say this is AB and the longest chord, and we have another chord. Say this is C, and connect A and C. Okay, now we have inscribed triangle. Inscribed triangle is a triangle with all the vertices on the circle. Now, if AB is a diameter, AB is a diameter, and assume the degree measure of arc AC is 3x minus 10, and the degree measure of BC is 7x minus 10. Okay, we do have all this information. Based on this information, find number one, the value of x, the value of x. Number two, the degree measure of angle ACB. Angle ACB. The third question here is find the degree measure of angle ABC. Okay. Lastly, find the measure of angle BAC. Okay. Now, you need to observe this diagram. In this diagram, it's given that AB is the diameter. As you all know, the diameter of a circle divides the circle into two equal parts, right? Any diameter divides the circle into two parts. The other thing that we have here is the degree measure of arc AC is 3x minus 10 degree, okay? 3x minus 10 degree. And the degree measure of arc BC is 7x minus 10 degree, okay? So the first question that you are asked here in this example is finding the value of x. So to obtain the value of x, you need to consider the whole degree measure of this part. Because AB is a diameter, the whole this thing becomes a semicircle, okay? The degree measure of a semicircle is 180 degrees. Therefore, the sum of these two must give us 180 degrees. So let's write it. The first part, 3x minus 10 degree plus 7x minus 10 degree must give 180 degree, right? Now you can collect like terms, and you need to rearrange in one place, right? So 3x and 7x are like terms, so you can add it. The sum of these two gives us 10x. Minus 10 is minus 20. Okay, 10x minus 20 is equal to 180 degree. Okay, these are also degrees, right? So this gives us 10x degree minus 20 degree is equals to 180 degree. Now you can take minus 20 to the right, or you can add the same quantity on both sides. Okay, you can add 20 degree on both sides so that on the left side it remains 10x. Therefore, this becomes 10x degree is equal to 180 degree plus 20 degree, which is 200 degree, right? So 10x degree is equal to 200 means dividing both sides by 10, okay, by 10 degree, then the value of x becomes 200 over 10, which is 20 degree, right? So for the first part, the value of x is 20 degree, okay? Write this thing, x is equal to 20 degree. This is the x value, okay? Now let's see the answer for the remaining three parts, okay? So we go to the second part. You are asked to calculate the degree measure of ACB. ACB. Well, if you want to answer this angle, that means you are asked this angle. Okay, here you can answer this thing by observing. Because AB is a diameter, that means the subtended arc is half of 360 degree. Okay, angle ACB is subtended by a semicircle. Therefore, this is the step that you need to follow. The degree measure of angle ACB is equal to half of 360 degree because it's subtended by a semicircle, which is its degree measure is 180 degree. Here, angle ACB is subtended by arc AB, so you need to write this thing. The degree measure of arc ACB is half of the degree measure of arc AB. Okay? Thank you. Half of the degree measure of arc AB. As you all know, arc AB is a semicircle, and a semicircle, the degree measure of a semicircle is 180 degree. Therefore, in place of arc AB, you need to substitute 180 degree, right? So half of 180 degree gives us 90 degree. Therefore, the answer for the second part is 90 degree, or angle ACB forms 90 degree at C. Okay, this is the answer for the second part. The third part, we are asked to calculate the degree measure of ABC. ABC. Okay, we are asked to find this angle. Okay, so Based on the definition that we have seen, based on the theorem that we proved before, the degree measure of angle B or angle ABC is equal to half of, look, this angle is subtended by arc AC, right? So you have to substitute half of the degree measure of arc AC, okay? Here, arc AC is 3x minus 10. But from the first part, we already have the value of x, so you can substitute 20 in place of x. So this means half of AC means 3 times 20 degree minus 10, right? So whenever you do this calculation, 3 times 20 is 60, right? 60 minus 10 is 50, right? So this becomes half of 50 degree. And half of 50 degree is 25 degree. Therefore, the answer for the third part is 25 degree, right? So this is 25 degree. Okay, what was this one? ACB. We already obtained 90 degree. Good. So we are left with one more question on example 3. Okay, that is measure of angle BAC. The fourth one, measure of angle BAC. Okay, angle BAC is half of the arc subtending it, half of the arc BC. So half of arc BC. Now you can calculate the degree measure of arc BC. Arc BC is 7x minus 10. So in place of x, you need to substitute the value that we have already obtained. Here we said that 20 degree, right? So here it becomes half of BC is 7 times x minus 10 degree, right? So 7 times 20 is 140, minus 10, it becomes 130. So this becomes half of 130 degree. So half of 130 degree means it's around 65 degree. Therefore, the degree measure of the last one is 65 degree. By the way, if you want to make sure that whether your work is correct or not, you can take this triangle and the sum of all these three angles must give us 180 degree. If it is different, there is something wrong in our calculation, right? So already we have this 90 degree and we have this 65 degree, okay? Angle A is 65 degree and this is 25. So the sum of these three angles forms 180 degree because the sum of the interior angles of a triangle must be 180 degree, right? That way you can check whether your work is correct or not. Okay, so let me add one more example regarding this, then we will see the next theorem. So in example 4, consider the diagram below. Here is our diagram, okay? Assume this is our circle. Say this AB is a chord passing through the center O, and assume we have a line that is extended to some point B, say D, okay, because B is already given here. Say this point is C, and construct a line segment joining A and C. So in this diagram, what is given, AB is AB is a line segment AB is the diameter of a circle, diameter, and angle BAC, this angle is given 45 degree, and measure of angle BAC is 45 degree. Okay, these two things are given. So based on this, find the degree measure of angle ABD. Angle ABD. Okay. So as you can see on the diagram, what is given, the diameter of a circle is given. Okay. AB is a diameter. The other thing, inscribed angle is also given. BAC is an inscribed angle whose degree measure is 45 degree. So based on this, we are asked to find this angle, this angle, right? So here is the procedure. This angle is 45 means the arc subtending it, okay, by definition, the inscribed angle is half of the arc subtending it. Therefore, you can calculate the arc BC, okay? So measure of angle BAC is equal to half of the measure of arc BC, okay? Now, this is already known, which is 45 degree. So substitute 45 here. 45 degrees equals to half of the degree measure of arc BC. Now, to calculate this arc BC, you can multiply both sides by 2, right? This is a formal procedure, but you can sense what the answer is. I'm showing you the formal procedure. So multiplying both sides by 2, you can multiply this equation both sides by 2. Then this becomes 2 times 45 degree is equal to 2 times 1 over 2 times the measure of arc BC. Okay? So now this can be cancelled out. 2 times 45 is 90 degree. So the degree measure of arc BC is 90 degree. All right. This is 90 degree, right? So now considering AB, which is the diameter which divides the full circle into 2 equal parts. So if this is 180 degree and a certain portion of it is known, which is 90 degree, so the remaining part, AC, should be 90 degree because the sum should be 180 degree. So the whole this arc AC is 90 degree. Now, why we need to know arc AC? This arc AC can tell us the degree measure of this part, okay? The degree measure of this part. A, B, C can be known. Because this is inscribed angle, which is half of the degree measure of the arc subtending it. Therefore, this angle becomes 45 degree. Because if this is 90, this is half of the arc subtending it. So this part is 45 degree. Now, we are asked to give the answer or the degree measure of ABD, this part. As you all know, these two pieces of angles forms a straight angle, okay? As you all know, a straight angle is 180 degree. Therefore, 45, together call it shortly X. Rather than writing measure of angle ABD, I want to write X. X plus 45 degree is 180 degree. Therefore, taking or subtracting both sides by the, subtracting 45 both sides, then X becomes 180 degree minus 45, which is 135 degree. Okay, the value of X or measure of angle ABD is 135. Therefore, measure of angle ABD is 135 degree, right? So this is the required answer for this case, right? So now we proceed to the next theorem, which is about cyclic quadrilateral. Okay, theorems on cyclic quadrilateral. Okay, before I state the theorem, let me roughly tell you about cyclic quadrilateral. As you all know, a quadrilateral is a four-sided polygon. Therefore, a cyclic quadrilateral is a four-sided polygon inscribed in a circle, and all the vertices are on the circle, right? So geometrically, cyclic quadrilateral looks like this. All the vertices are on the circle, and the quadrilateral is inside the circle. So this is roughly a cyclic quadrilateral. Okay, so what the cyclic quadrilateral theorem is saying here is in a cyclic quadrilateral, the pairs of opposite angles are supplementary. Okay, you know what we mean by supplementary, complementary, and the like. Two angles are said to be supplementary if the sum of their angles is 180 degrees. So geometrically, to understand this theorem, you can roughly construct a circle. Say this is a cyclic quadrilateral. Okay, the vertices are A, B, C, D. Okay, this theorem is literally saying that the degree measure of the pairs of opposite angles are supplementary, meaning that the degree measure of angle A and angle C, okay, whenever you add these two, the sum gives 180 degrees. Similarly, the opposite pairs B and D, the degree measure of these two is supplementary or 180 degrees. So I will show you how this theorem can be proved. Then after, we will see problems related with cyclic quadrilateral, right? So let's see how this can be proved. Okay, so in this theorem, we want to show that, shortly I use this abbreviation WTS. We want to show that the degree measure of angle A plus the degree measure of angle C is 180 degrees. Similarly, the degree measure of angle B together with angle D is 180 degrees. So we will see how this result is obtained. Then based on this theorem, we will try to see some examples. Now, angle A, take the first part, okay? The measure of angle A is, since angle A is inscribed angle, since this is inscribed angle subtended by arc BCD, so you can say measure of angle A is equal to half of the arc subtending it based on the theorem that we have already seen. So this is half of the degree measure of arc BCD, okay? This is angle A. At the same time, angle C, measure of angle C measure of angle C, this angle is half of the arc subtending it, okay? This inscribed angle is subtended by BAD, okay? This is half of the measure of BAD, okay? So now you can directly add these two angles, okay? Let's see what the sum looks like. The measure of, this implies the degree measure of angle A plus measure of angle C, okay? Whenever we add these two, we are adding these two quantities. So this becomes half of arc BCD plus half of arc BAC, okay? Now, half is common in both, so you can take it out. So this becomes half of BCD plus BAC, okay? Here, I need you to critically observe the diagram and these two sum. BCD means this portion, okay, the whole this part, and BAC means measure of angle C is half of BA not C. This is D, right? Because C is subtended by this. So you can make this D. This also should be D, okay? You can make this correction. So here you have to make BAD. Nice. So I need you to critically observe these two sum. These two curves together forms a complete circle, right? BCD and BAD forms a full circle. As you all know, the degree measure of a complete circle is 360 degrees. So these two is a complete circle. Therefore, this becomes half of 360 degrees. Okay, half of 360 degrees is 180 degrees. Okay, so as you can see here, the sum of angle A and C is 180 degrees. Okay, similarly, we have already proved the first part. Okay, similarly, you can prove the sum of these two angles, measure of angle B and D, forms 180 degrees. Okay, so you need to follow this procedure and you need to apply the definition of inscribed angle properly so that you can easily prove this one. I will leave this, the second proof for you, then we will see examples related to cyclic quadrilateral, okay? So now let's see this example. Okay, in the figure shown below, find the value of x. The value of x. Okay, the figure is we have a certain circle and a cyclic quadrilateral with a certain degree measure. Okay, say this is our cyclic quadrilateral. Assume this angle is x plus 50 and this is 70 degrees. Okay, in this figure, what is given? A cyclic quadrilateral is given, and the degree measure of the opposite pairs is given. One is 70 degrees, the other one is x plus 50 degrees. So, based on this, you are asked to calculate the unknown variable x, right? So, here, to find the unknown variable x, you need to properly apply the formula or the relationship that we have seen before, okay? Always in a cyclic quadrilateral, the pairs of opposite angles forms supplementary, okay? Or the sum of the opposite pairs should be 180 degrees. So that is the first step that you need to follow. So here we can say x plus 50 degree plus 70 degree must be 180 degree, right? So collect like terms, this becomes x degree plus 120 degree is equal to 180 degree. Now x becomes 180 degree minus 120 degree. So this difference gives us x is equals to 60 degree. So the unknown variable that we have here is 60 degree. You can check that 60 plus 50 is 110. 110 together with 70 must give us 180 degree. Otherwise, your answer or our answer is not correct. Okay, so now I will give you one more simple example, then we conclude our lesson. Okay, so look at this one. Example 2. In example 2, consider the diagram shown below. Here, our diagram contains a cyclic quadrilateral with certain information. Here, we have a cyclic quadrilateral. The angles here are, this is 3x minus 15 degree, and here 75 degree, and this angle is 120. Here 2y plus 20. Okay, so in this figure, what is given? A certain circle together with cyclic quadrilateral is given. So based on this information, find the value of x and y. Okay, so now we follow the same procedure that we used in the first example. Okay, so based on the theorem on cyclic quadrilateral, we know that the sum of or the pair of opposite angles forms supplementary, or the sum of opposite angles must be 180 degree. So based on that information, we can calculate the unknown variables. So here the first equation can be 3x minus 15 degree plus 75 degree must be 180 degree. Okay, from these two we can obtain this thing. From the other pairs of opposite angles, we can get that 2y plus 20 degree plus 120 degree is 180 degree. Okay, solving these two equations for the unknown variables will give us the value of x and y. So take the first equation and collect like terms. Okay, 3x minus 15 together with 75 degree is positive 60 degree. Okay, this must be 180 degree. So you can transform 60 degree to the right side, then this becomes 3x degree is equal to 180 degree minus 60 degree. And this difference gives us 120 degree, right? So 3x is equal to 120 degree. And the last step will be dividing both sides by 3. Then you will get x value. Okay, so dividing both sides by 3, x becomes 40 degree. Okay, this is the answer for x. To calculate y value, you can take the second equation. So the sum of these two, okay, forms supplementary, or you can solve this one for y. So collecting like terms, this gives us 2y 2y degree plus 140 degree is equals to 180 degree. Then take this 140 degree to the right and subtract from 180 degree. Then this becomes 2y degree is equal to 40 degree. And lastly, divide both sides by 2, then you will get the value of y. Okay? So y becomes 40 over 2 or 20 degree. Okay? This is all about this problem. So in this lesson, we have seen a certain examples regarding central angle. We have also seen the concept of inscribed angle and related issues. Then we have seen theorems on cyclic quadrilateral, and we have also seen how the proof is obtained. Lastly, we could see problems related to cyclic quadrilateral. So these are all about the present lesson. I hope you enjoyed the lesson. This is all for today. Thank you.